This is the Math 2 Unit 5 review worksheet. So we start with the first problem, and we have a pentagon, has 5 sides. We need to find the missing angle value. So we have the rule of n minus 2 times 180, which gives us the total of the interior angles. N in this case is the number of sides. So we have 3 times 180, which gives us 540 degrees. So all of these angles have to add to 540. So we got 90 here, another 90, another 90, a 120, and an x that all have to add up to 540. Well, 90, 90, and 90 gives you 270. Plus an additional 120, we have 390 degrees. Plus x equals 540. If we subtract 390 from 540, we get 150 degrees for x. When we look at number 2, we now have a quadrilateral, so we know these have to add to 360. So we'd say 5x minus 4 plus 8x plus 1 plus 95 plus 73. We have the 5 and the 8 are going to be a 13x. So then we have 95, 73, 1, and a negative 4, which come out to be 165. We're going to subtract the 165 from 360, and we get 195 equals 13x, and divide that by 13, and we get that x is 15, which is answer A. To determine the sum of the exterior angles of an octagon, we don't really need the formula, we just need to know the rule that the exterior angles always have a sum of 360 degrees. We don't even have this covered up. And as long as we're talking about the exterior angles of some polygon, we know the answer is automatically 360. Now, determine the measure of each interior angle of a regular-sided polygon with 9 sides. This one, we need the formula. So we're going to do n minus 2 times 180 divided by n, which is the number of sides. This gives us the total of all the interior angles, but we want to divide by how many sides we have because it's each interior angle of the regular-sided polygon. So that's going to be 9 minus 2 times 180 divided by 9, which is 7 times 180 divided by 9. 7 times 180 is 1260. Dividing that by 9, we get 140 degrees. For number 5, determine the measure of each exterior angle in a regular polygon. So with the exterior angles, we know it's 360. Because they want each, we divide it by the 12 sides that we have. So 360 divided by 12 gives us 30 degrees. Because 12 angles of 30 degrees would multiply to be 360. For number 6, the measure of an interior angle of a regular polygon is 162. How many sides does the polygon have? So we're going to say that 162 is equal to, almost like what we did right here with the 140. So we're going to say it's equal to that. So it's equal to n minus 2 times 180 over n. Now what I'm going to do first is I'm going to multiply both sides by n. 162 here. Let's write the right value. 162n equals n minus 2 times 180. I'm now going to distribute, and I get 162n equals 180n minus 360. If I subtract the 180n to both sides, we get negative 18n equals negative 360. And if we divide 360 by 18, or negative 360 by negative 18, you get that n is 20. Now, that's a little more complex route to go about it. There's another way we could look at it. So if I have an interior angle of 162 degrees, I know the exterior angle has to be 18 because they have to add to 180. And because the exterior angles always add to 360, I can just divide that by 18 degrees and we get 20 sides that way as well. Just another option. For number 7, we need to find the missing angle. So I'm first going to write y right here because I'm going to find with the interior angles what this angle is and subtract it from 180 to find its supplement. So I have 1, 2, 3, 4, 5, 6 total angles. So 6 minus 2 times 180, or 4 times 180, gives me 720. So 720 is equal to the 100 plus 140 plus 100 plus 140 plus 100 plus y. So we got 140, 100, 100, 140, and 100. Try that again. Which comes out to be 580. So 720 equals 580 plus y. 720 minus 580 leaves us with y is equal to 140. So if this is 140, the exterior angle, its supplement, would be 40 degrees. For number 8, the number of sides of a regular polygon if each exterior angle has a measure of 15 degrees. So now we're going to go 360 divided by 15. And that gives us 24. So 24 sides, 360 degrees by 15. There's our answer. For number 9, we are looking at a parallelogram. We have that FH, which is, they say, is 30. We need to find FK. Now, the 12 really doesn't help us here. What we need to know is that in a parallelogram, the diagonals bisect each other. So we know that these two parts, FK and KH, are congruent. And if their total is 30, that means each of them are 15. For number 10, PQVT is a rhombus. We need to find the value of x. What helps us in a rhombus sometimes is if we cut it up into the different smaller pieces. So this rhombus has the diagonal. This actually gives me two isosceles triangles. In that, I know that both of these have to be the same. So x plus 110 equals 180. Or 2x plus 110 equals 180. We get 2x equals 70 and x equals 35. For number 11, we need to solve for our angles. So I have a y here, that's the one by there, but I have these two with x's. Now opposite angles are congruent in a parallelogram, so we're going to start with 6x minus 8 equals 4x plus 6. That gives us 2x minus 8 equals 6, which is then 2x equals 14, or x is 7, which is A and B. So we know C and D are out. Now we also need to write the rule, and that's that both pairs of opposite angles are congruent. Now we need to go back and we need to find y. And the way we're going to do that is we're going to use the fact that consecutive angles are supplementary. So I'm going to substitute the 7 into one of these. I'm going to put it in this one. So I got 4 times 7 is 28, plus 6 is 34. So that means this angle, because it's supplementary to it, is 180 minus 34, which is 146. So I'm going to say 146 equals 2y plus 16. I could subtract 16, and I get 130 equals 2y, and y is then 65. So we'd go with answer B. Number 12, we have a rhombus. KLM is 70 degrees. We need the measure of angle 1. Now in a rhombus, we know the diagonals are perpendicular, so let's look at if we made a right triangle out of this. So we have a right angle, there's K, there's L. I'm looking for angle 1 here. So I got 90, that's taken care of. I'm needing angle 1. Now this angle's not 70, because also in a rhombus the diagonals bisect the angles. So the 70 gets split to be a 35 and a 35 here. So now in our right triangle, it's a 35, a 90, and our missing angle, and that angle is going to be 55 degrees. For 13, it's saying if we know the rules for a parallelogram. So let's kind of work our way through and see which are true, which are not. So A and B have to add to 180. If that's the case, that's saying that consecutive angles are supplementary, which we just said right up here for a parallelogram, so that works. A plus C is 180. That means they are also supplementary, but that is not true because, like we talked about here, both pairs of opposite angles are congruent. That does not mean supplementary. So although that may be true in some cases, it is not always true. A congruent to D. Also, both pairs of opposite angles are congruent is what we're looking for here, but A and D are adjacent angles or consecutive, so that's not necessarily true. BC and AD, this one is true. Opposite sides are congruent, and those two sides are opposite from each other. And then the last one, A is congruent to C. Like we said earlier, opposite angles are congruent. So A, D, E. For number 14, we are looking at a trapezoid, and we're solving for what we call a midsegment here. So this is the midsegment of a trapezoid. So that is going to be that the midsegment is equal to base 1 plus base 2 over 2. It's the average of the bases. So I don't have numbers here, I have an expression, so I'm going to solve. 5x plus 2 equals, on the top it's 4x plus 1 plus 27 over 2. If I simplify the right-hand side, I get 4x plus 28 over 2. So that's 5x plus 2 equals 2x plus 14. I'm going to subtract 5x, or 2x from the other side, and I get 3x plus 2 equals 14. Let's go over here. We get 3x plus 2 equals 14. So now we're going to subtract 2. 3x equals 12, which gives us that x equals 4. Now, make sure you read the question. It wants KL. KL, if x is 4, that's 4 times 4 plus 1. That's 16 plus 1, or 17 is the length of KL. For number 15, we have angle A is 80 degrees, and we have a trapezoid. We see 6 and 6 here. That also means it's an isosceles trapezoid. And if that's the case, we know that base angles are the same, so these are both 80, as well as B and A, and C and D in this case being supplementary because of the parallel lines. So we have 100 degrees and 100 degrees. So angle B is 100 degrees, angle C is 100 degrees, angle D is 80 degrees. And then what type of quadrilateral it is? An isosceles trapezoid. And we know this because we have one pair of parallel sides and one pair of congruent sides that are not the parallel ones. For number 16, we need to find the values of x and y. So we notice here we have some rectangles. And what's good for rectangles is we can go through and start filling in values. So some rules we know about rectangles is we know diagonals are congruent and diagonals bisect each other. So that actually makes these parts all congruent. And where that helps us is that gives us some isosceles triangles here and here to work with, as well as top and bottom. So if this is 52, this angle is also 52. Then the 52 and the y have to add to 90. So 90 minus 52 is 38 degrees. And then I got to find x. Well, 52 and 52 is 104. That leaves me 76 degrees here. And I could say x plus 76 equals 180. To make it a linear pair. Or we found 38 as this angle, 38, 38, and you could also see that it's x plus 76 equals 180 if it was a triangle. In either case, we get x is 104. Now, properties we use the fact that diagonals are congruent and they bisect each other. And also the fact that a rectangle has 4 congruent right angles. Number 17, we have our isosceles trapezoid with a lot of information here. Let's kind of take it apart. I'm going to solve for n first. N is looking at the midsegment. So for this one, we're going to go 3n minus 4, which is the midsegment, is equal to 10 plus 36 over 2. So that's the average of our bases. So we got 3n minus 4 equals 46 over 2, or 3n minus 4 equals 23. We're going to add 4 over, we get 3n equals 27, and n equals 9. So that's n. They then want EF, so EF is going to be 3 times 9 minus 4, or 27 minus 4, which is 23. And for this, we use the midsegment formula, or you could say theorem. And that's the average of the bases. Now for x here, it is a trapezoid, and we know that these angles are supplementary. So let's say that 2x minus 17 plus 3x plus 2 equals 180. We get 5x minus 15 equals 180. So 5x equals 195, which comes out to be x equaling 39. Now, they want ADC, which is this angle right here, but it has to be the same as the other base angle at A. So ADC is going to be 2 times 39, which is 78, minus 17, which gives us 61 degrees. And for this, we used same side interior angles are supplementary. For number 18, we have a parallelogram. We need to solve for both x and y. So let's start with writing some equations. So we have x equals 15 minus 3y, and we have 2x plus 9y equals 42. So I have 2 equations and 2 unknowns. It looks like I can easily substitute the x is equal to 15 minus 3y into this equation. So let's do that. So with substitution, we get 2 times 15 minus 3y plus 9y equals 42. 30 minus 6y plus 9y equals 42 is our new equation. We combine like terms and we get 30 plus 3y equals 42, and then 3y equals 12. So this gets us to the point of then y is equal to 4. So if y is equal to 4, let's put that there. And let's go back and substitute in and see what we have. So if x equals 15 minus 3y, we get 15 minus 12, and x equals 3. So the rules we use is that opposite sides are congruent. For our next problem, we have a rhombus. And a rhombus, first off, we know that diagonals are perpendicular, and we know that all the sides are congruent. So let's get n out of the way first. 15n minus 7 equals 12n plus 20. If we subtract over the 2n, or the 12n, we get 3n minus 7 equals 20, or 3n equals 27. So n is 9. And this was congruent sides. Now, y is 90, because we know the diagonals are perpendicular, and they want the reason here, and that's because diagonals are perpendicular. And let's kind of work through the rest of it. Now, in a rhombus, we know that the opposite angles are congruent because it's a parallelogram, as well as the fact they are bisected. So that makes both of these 43. It also makes these 43. So z is 43 degrees. And then once we do that, they really become little right triangles. So I have x, 90, and 43. If I add all those up and set them equal to 180, I get that x is 47. For number 20, I need to find some coordinates. So I have S, P, and R already. The fact that R is the coordinate C0, that tells me that this rectangle is C units in length, and then P is 0K, it is K units in height. So to get to point Q, I have to go over C and up K. So that's CK. Now I need to find the midpoint of PR, which is just this diagonal. So this is going to be, I'm just going to write the formula off to the side here. Average of the x's, I have 0 plus c over 2. And then the y's, it's k plus 0 over 2. These simplify to be c over 2 and k over 2. For SQ, this diagonal, it's going to be 0 plus c over 2 and 0 plus k over 2, which becomes c over 2 and k over 2, which they should be the same because if this is a parallelogram, which is a rectangle, that means that diagonals bisect each other, so they would have the same midpoint. So let's take that idea and do the next problem. So here, I'm looking at L is at negative a 0, and W is at a plus b c. So first off, we know the height is c, so we can put a c there and a 0 there. So we need to figure out how far this value is over. Well, this is a, and this is a plus b. This part must be b, because it's a plus b is the same as this length. So we're going to put an a there. For letter A, how much did it move for the x value? It didn't move any because it's on the y-axis, so there's our coordinate there. So A is 0, C, N is a 0. Now we're going to do the midpoints using our midpoint formula. So for AN, we have 0 plus a over 2 and c plus 0 over 2. So that gives us a over 2 and c over 2 as our midpoint. For LW, we're going to do a plus b minus a over 2, because those are our x values, and 0 plus c over 2. Now, this simplifies to just be b over 2. And this is c over 2. So we're going to go b over 2, c over 2. Now, this seems odd because they're not the same. They should be the same. And what happens here is even though I said b, I made that a. So that should be b. This should be b. This should be b. And that should be b. So now we've corrected it. We've caught our mistake. B over 2 and c over 2. For number 22, we start off with these 3 points A, B, and C. And we're going to go through 3 different versions where we find point D as a 4th point somewhere in certain quadrants. And then we're going to show that it is a parallelogram using the different formulas. So it just gives us a different practice for the verifying when a quadrilateral is a parallelogram. So for the first one, we have to go quadrant 4. So quadrant 4 is going to be right in this quadrant here, where the points already are sitting. If I want to find the 4th point, if I notice it goes down 3 over 1 as a slope kind of idea for like a parallelogram, I'm going to go down 3 over 1 from here, and this gives me a point at 5, negative 5. So I go down 3 over 1, down 3 over 1, and then I go down 1 over 3, down 1 over 3. So if we label these A, B, C, and D, now we can show that it's a parallelogram using the slopes because the opposite sides should have the same slope. It makes them parallel. So the slope of AC, we said, is down 1 over 3, so that's negative 1/3. The slope of BD is down 1 over 3, so that's negative 1/3. That makes these parallel. The slope of AB is down 3 over 1, and the slope of CD is down 3 over 1. That also makes them parallel. So we know this is now a parallelogram because the opposite sides have the same slope, which makes them parallel. And we may almost think that they are perpendicular, but these are in fact not opposite reciprocals. That kind of goes in the direction we don't want to go. All right, next one. Plot the 4th point in quadrant 3, which is over here, to make a parallelogram. So if I notice right here, it goes down 2 over 2. So I'm going to do that off of this point. So down 2 over 2 puts me right there. So we have A, B, C, and D. And now we're going to use the midpoint formula. Where the midpoint formula helps, it shows that diagonals bisect each other. So if they bisect each other, that means the diagonals are going to have the same midpoint when they intersect. So we're going to find the midpoint of AB. Midpoint formula means you're going to add the x's, divide by 2, add the y's, and divide by 2. So for A, our x values are 1, and for B it's 2, so 1 plus 2 over 2. For the y values, it's negative 1 and negative 4 over 2. So this gives us 3 over 2 and negative 5 over 2, which are fractions and we can't quite simplify, but let's see what we get with CD and see if it matches. So the midpoint of CD, C was the coordinate 4, negative 2, and then D we found was negative 1, negative 3. So our x values are 4 plus negative 1 over 2, and then our y values are negative 2 and negative 3 over 2. So we see this, we get 4 plus negative 1 is 3, and negative 2 and negative 3 is negative 5, and we get 3 over 2 and negative 5 over 2 for both, showing us the diagonals bisect each other because they have the same midpoint, thus making it a parallelogram. For part C, we need to find a fourth point in quadrant 1, which will be up here. Let's label A, B, C. So if we look B to C, we went up 2, over 2. So we go over 2, up 2. We're going to do the same thing with A, and it puts us our new point of D here. So now we're going to use the distance formula. So for the distance formula, we're going to find the distance of AD and BC. Then we're going to find the distance of AB and CD, and we want those sets to be the same, and that's going to tell us it is a parallelogram. Now, in the interest of space here, we're going to use that the distance formula is the change in x squared plus the change in y squared. So I'm not going to do the x2, x minus x1, and the y2 minus y1. I'm just going to count how much it changes in the x and y direction, thinking of it like Pythagorean theorem, whereas if I have a line, the change in x is the horizontal amount it changed, and the change in y is the vertical amount it changed. I'm not too worried about if it's positive or negative because we're going to square it anyways, and that's going to make it positive. So for A to D, I go over 2, up 2. That's my path to get to D. So that's 2 squared plus 2 squared, which gives me the square root of 4 plus 4, or the square root of 8. Now if we're going to simplify the radical, that also becomes 2 root 2, but really square root of 8 might be enough to check. So B to C, it goes 2 to the right and up 2, so our change in x is 2, our change in y is 2. So that's 4 plus 4, it's looking the same, and that's the square root of 8. So that tells us that AD is congruent to BC. That's the first step to making it a parallelogram. Now A to B, I go over 1 in the x direction, and then up 3. So we're going to go 1 squared plus 3 squared, which then becomes 1 plus 9, or the square root of 10. For CD, I go 1 to the left, up 3, so that's a 1 squared plus 3 squared, which gives me 1 plus 9, or the square root of 10. So that also shows me that AB is congruent to CD because the opposite sides there are also congruent. All right, now to number 23. We have an always, sometimes, or never. So we need to figure out off of these statements whether they're always, sometimes, or never true. It's not that we're filling in every single box. It's kind of individual questions as we move down. So a rectangle is a square. So let's kind of first think through the always and nevers, and then that sometimes is where we'll fall next. So a rectangle is a square. So I can draw plenty of rectangles, but if I just think of the normal version of a rectangle, it's not always a square. Now, is it possible, though, that a rectangle could be a square? So if I were to draw a square, by its definition, 4 congruent sides, 4 congruent angles, that qualifies as a square. That also qualifies as a rectangle. So this can at times actually qualify as a rectangle. So it's not all rectangles. It's not ever possible, never possible, but it is a sometimes that a rectangle is a square. Now, is a square a rhombus? A rhombus means a shape has 4 congruent sides. But if I'm talking about a square has 4 congruent sides and angles. So it's possible that a square is a rhombus. In fact, it will always be possible because it'll always qualify as a rhombus because it has the 4 congruent sides. So that one's an always. Is a trapezoid a parallelogram? Well, a trapezoid has 1 set of parallel sides. A parallelogram has 2 sets of parallel sides. The fact they have different amounts means these are not going to agree, so that's going to be a never. The diagonals of a parallelogram are perpendicular. So if I were to draw a normal parallelogram, they're not necessarily perpendicular. When they are perpendicular is when we have a rhombus. So because that happens in a rhombus, it's not always, it's not never, but it's sometimes possible. And then that sometimes it is possible, it is when it is a rhombus. The sides of a parallelogram are congruent, very similar to what we just looked at here. If I have a parallelogram where all the sides are the same, it's a rhombus, which means it's not always true, it's not never true, it's sometimes true. The sometimes meaning that's when it is a rhombus. The other times would be maybe it's a rectangle, or maybe it's just a regular normal parallelogram that we don't know all the sides are the same. For our last problem, we have a proof, and we just need to fill in the blank here to which statement works. And if we notice, it's a lot of triangle congruence, what we did in the previous unit. So we were given that AB is congruent to CD, so let's mark those, and BC is congruent to DA, right, because of given information. We have AC is congruent to AC by the reflexive property. That means that triangle ABC is congruent to CDA by a theorem, which we have here, by what we're looking at. Now, going back to that triangle congruence, in this type of scenario, I only know sides. I don't know any angles. So my best answer for this is side, side, side congruence, or answer D here. Now, if we keep going, it says that angle 1 and angle 4, as well as angle 2 and 3, are congruent because of corresponding parts of congruent triangles. Okay, we already have the side, side, side congruence. Then that tells us that these sides will be parallel because of alternate interior angles, which we got from the CPCTC. This eventually leads us to say this is a parallelogram. Now, that in the big picture, this is a way to show that we have a parallelogram using triangle proofs. But what we really need here is you have to take the given information in the proof, anything prior to the blank, label the diagram, and you can figure out which congruence you have.